For this section, we're going to be talking about binomial radical expressions. So the term binomial should be a reminder of last chapter when we learned about binomials and trinomials. And all of these that we're going to be dealing with are binomials. So they will have two terms in each expression. And so we're going to be dealing with multiplying the binomials with radicals inside them. So again, remember FOIL. This is all going to be about FOIL. Making sure that we are distributing everything into the parentheses. So just like FOIL, we're going to go ahead and make sure we multiply the first terms, the outer terms, the inner terms, and the last terms. So I'm going to start with 2 and 6. So 2 times 6 is 12. And then I'm going to do 2 times the negative square root of 5. So that gives me negative 2 square roots of 5, square root of 5. So just kind of like it was a variable, we're going to treat it like a variable. And then I'm going to do positive square root of 5 times 6. So it's going to be plus 6 square root of 5. And then positive square root of 5 times the negative square root of 5. Well, you guys, I'm going to put it this way. It's going to be the negative square root of 5 squared. Okay? So I'm multiplying the negative, square root of 5 times the square root of 5, which is the square root of 5 squared. Okay? Now I'm going to kind of simplify my exponent there and go ahead and combine my like terms in the middle. Negative 2 square root of 5 plus 6 square root of 5 would be positive 4 square root of 5. And then my square root of 5 squared is just going to become 5. Okay, so then my last step is going to be combining my 12 and my 5. My like terms there, 12 minus 5 is 7. So my final answer is 7 plus 4 square root of 5. Sorry, I wrote a little big there and didn't give myself enough room. So looking at the next problem, we have 6 plus the square root of 6 quantity squared. So I'm going to come out over here and I'm going to write that out like this so I can see it and I can multiply it. I can just FOIL it. Again, first, outer, inner, last. So when I do the first two terms, 6 times 6 is 36. And then 6 times the square root of 6 for my outer right here. And then I'm going to do my inner, and I'm writing it backwards because I want my coefficient of 6 to be in front of my radical 6. And then the square root of 6 times the square root of 6, well, again, I'm going to write it like this just because I want you guys to see it. But you're going to notice a pattern here that when we do that last term, that radical ends up disappearing. So I'm going to go ahead and simplify that right there to just being a plus 6. Again, the radical squared becomes, basically the radical disappears. And now I'm going to combine my like terms. So 36 plus 6 is 42. And then 6 square root of 6 plus another 6 would be 12 square roots of 6. Now my square root of 6 doesn't simplify, so I'm done. Okay, let's go ahead and look at the next two problems. So moving on down the page. The first one we have is 4 plus 2 square root of 2 times 5 plus 4 times the square root of 2. So again, same thing with FOIL. So 4 times 5 is 20. And then 4 times 4 square roots of 2 becomes 16 square root 2. And then the square root of 2 times, 2 square roots of 2 times 5 would be 10 square root of 2. Because again, I'm just multiplying the 5 and the 2 right there. And then I multiplied the 4 and the 4. Notice nothing under the radical at this point is multiplied. For my last term, I'm going to do 2 times 4 and get 8. And then I'm going to do the square root of 2 squared. Okay? So just kind of keep that in mind for those coefficients there and how they work. So now I'm going to combine like terms. So the first thing I'm going to do is I'm going to simplify, put my terms together here in the middle. 16 plus 10 becomes 26 square root of 2. But over here, the square root of 2 squared becomes 2. So I end up right here with 8 times 2, which is 16. Okay, the 8 just comes down, and then my square root of 2 squared becomes just that 2. So now 20 plus 16 is 36 plus 26 square root of 2. All right, let's look at letter D. So we have a variable in it this time, which is kind of interesting. So that will kind of just won't change.
Okay, Edward, contact the office, please.
Won't change too much, sorry. So when I do my first, -2 times 4 is -8. -2 times 2 square root of x would be -4 square roots of x. And then negative square root of x times 4 would also be -4 square root of x. And then negative, like let's look at this like a -1 if you want to. -1 times 2 is going to be -2. And then the square root of x squared, because it's the square root of x times the square root of x. So let's go ahead and combine my like terms. I have a -8 right here. And then -4 square root of x and -4 becomes -8 square root of x. And then again, this is going to become -2. And then my x squared is just going to simplify to an x. So minus 2x. So if I were going to go ahead and put this into like kind of standard form, so to speak, I'm going to go ahead and bring my -2x out front, my -8 square root of x, and then my -8, my constant at the end. Usually your constants are at the end. A lot of times you put your radicals at the end because they're your irrational numbers possibly, but I would never count it wrong if you had left it like I did right here in the red. If you had left it like that, that'd be fine. Because there is nothing else I can combine. There's no more like terms. I cannot add the radical x to the -8 radical x to the -2x because one has a radical, one does not. So they're not like terms. All right, moving to the next section, we're going to talk about finding and multiplying conjugates. So I hope you remember conjugates. Conjugates are where your parentheses are basically the same, but you have a difference of a sign in the center, or at least one of your terms has a different sign. So if we have 3 plus the square root of 13, the conjugate would be 3 minus the square root of 13. The reason we want a conjugate is because we want that middle term to disappear. Notice in the problems up above, we did not have conjugates, so we had those middle terms with the radicals still in them. If you will use a conjugate, that radical will end up disappearing. You won't have the radical. Just like when we use conjugates for imaginary numbers, the imaginary numbers disappeared in that middle term. They kind of just went away. Same thing with radicals. So let's go ahead and look at F. The first one was, let's go ahead and finish E. We wrote the conjugate, so now let's actually FOIL it and see what happens. So 3 times 3 is 9. 3 times negative square roots of 13 becomes -3 square root of 13. And then positive 3 times the square root of 13 becomes positive 3 square root of 13. And then here in the end, we have basically minus 13. Now, I shortcutted there, but I'll just show you it was the square root of 13 squared. And that just simplifies to 13. So what do we notice in the middle? We have a -3 square root of 13 and a positive 3 square root of 13, which add to 0. So again, we are left with 9 minus 13, which equals -4. So when you multiply conjugates, those radicals will disappear, leaving you with a rational number versus your irrational numbers that you started with. So let's go ahead and do this letter F. 6 times 6 is 36. And then -6 square roots of 6. And positive 6 square roots of 6. And then minus, we have square root of 6 times square root of 6, which is just going to be 6 minus 6. So notice again, our middle terms add to 0, a -6 square root of 6 and a positive 6 square root of 6. And we're just left with 36 minus 6, which equals 30. Okay, so let's go ahead now and let's use those conjugates to help us actually rationalize a denominator. So finding the conjugate of the denominator is the first step. And then you're going to multiply the numerator and the denominator by the conjugate, because this is a form of 1. Okay? If I have something over itself, I'm multiplying by a form of 1, so therefore I am not changing my equality. I'm not changing the value of the original fraction. And then simplify and combine like terms. So looking at problem G, this is how we're going to basically why binomials come in handy. So I'm going to multiply both the numerator and the denominator by 1 plus the square root of 5, which would be the conjugate here. So 1 plus the square root of 5. So I have to multiply both the top and the bottom. So let's go ahead and do the top of our fraction. 4 times 1 is 4. And then plus 4 square roots of 5. I just multiplied here. And then plus the square root of 3. And then the square root of 3 times the square root of 5, well, that's going to be the square root of 15. Now I can go ahead and multiply those two together because they're both under a radical. I cannot multiply these two things. I can't multiply anything here or add them or anything because their radicals are not the same. But that 3 and 5, since it's multiplication and they're both under the radical, I can go ahead and multiply them together. I cannot simplify that numerator any further because I have no like terms. I have one with a radical 5, one with a radical 3, and one with a radical 15. So nothing can be simplified there. In my bottom, the denominator, I have...
May I have your attention, please? I need the following students to please come to the office. Aliana Williams, Anna C. Turner, Horatio Torres, Mitzi Melchor, Jasmine Lawrence, Emily Hedrick, and Destiny Guerrero. Thank you.
I'm going to go ahead and work that out. I wasn't going to work that out since she was talking, but I'm going to go ahead and work this out. So I'm going to end up with, and then remember this, the last term is the square root of 5 times the square root of 5, which just becomes the square root of 5 squared, which becomes 5. I could look at it like this: the square root of 5 times the square root of 5 is the square root of 25, and that square root of 25 is 5. So again, just showing you what happens in the denominator. These cancel out, and 1 minus 5 would be negative 4. So my final answer would be 4. I'm just going to leave it like this instead of trying to put it in any particular order. There's my final answer with a rationalized denominator, getting that radical out of the denominator. Okay, I'm going to erase that so I can do, I'm going to erase that so I can do the next one and have space to work, because I tend to write really big on this paper. So let's look at the next one. My conjugate of the square root of 3 minus the square root of 5 would be the square root of 3 plus the square root of 5. Put that over the square root of 3 plus the square root of 5. Notice I'm multiplying by exactly the same thing on the top and the bottom. So let's go ahead and do our numerator. 2 square roots of 7 times the square root of 3 is going to be 2 times the square root of 7 times 3. They're both under the radical, so the square root of 21. Okay, and then 2 square roots of 7 times the square root of 5 is going to be 2. And then the square root of 7 times the square root of 5 is the square root of 35. Okay? On the bottom, let's see if you can guess what it's going to end up being. If I do the square root of 3 times the square root of 3, that's going to be the square root of 3 squared. If I do my outer and my inner, the square root of 3 times the square root of 5 is going to be the positive square root of 15. And then that's my outer. And then my inner is going to be the negative square root of 15. Well, those are going to add to 0. And then negative square roots of 5 times the square root of 5 is going to be the negative square root of 5 squared. Okay, as you guys can tell, this right here is going to simplify to just 3. And this is going to simplify to 5, leaving me with a negative 2 in my denominator. So my final answer is going to be a numerator of 2 square roots of 21 plus 2 square roots of 35. And there are no perfect square factors of 21 or 35, so that's as simplified as I can get it, all over negative 2, and put the negative out front. I'm just putting the negative out front. Okay, I could put it with the numerator, but I'd have to change both the signs of everything in the numerator. Okay, last few examples. My conjugate here is 3 plus the square root of 6. So I'm going to multiply that by 3 plus the square root of 6. This time I just have a 4x on top, so that's kind of nice. 4x times 3 becomes 12x. And then 4x times the square root of 6 literally becomes 4x square root of 6. Okay? Nothing fancy there, just that's all I can do. All over 3 times 3, let's FOIL it. So the first is 3 times 3, which is 9. And then I have positive 3 square roots of 6 and negative 3 square roots of 6, which is going to add to 0. And then I have minus the square root of 6 squared. That's my last term, which is just going to end up being 9 minus 6 on the bottom, which equals 3. So my final result would be 12x plus 4x square root of 6 all over 3. Okay? Oh, I just realized I didn't totally simplify problem H. And I hope maybe some of you guys caught that. What could I do on problem H? I'm going to go ahead and finish it over here. Notice that I have a 2, a 2, and a 2 as coefficients or just constants. Okay, if my coefficients and constants, if every one of them have a common factor, remember I can take care of those factors. So I can simplify this to the square root of 21 plus the square root of 35. And I cannot simplify that any further. I divided everything by 2, just saying that. So it'd be 1 square root of 21, 1 square root of 35, all over 1. I just didn't catch that earlier. On my problem I, 12, 4, and 3 have nothing in common. 3 does go into 12, but 3 does not go evenly into 4, so I cannot simplify that one. Okay. All right, so let's go ahead and do the last one. You guys can try the last one on your own, and then you can restart the video and see if you got the right answer. I'll have the work and everything on there for you to check.